day. So let's have a prayer. So please, Miss Jelai, please lead our prayer.
Let's bow our heads. Our loving and generous God, we pray for the Thank you for giving us a mind that can live and a heart that can love. Thank you for giving us the chance to continue learning and the pandemic that had us. We are sorry for the time that we have failed. We have for your forgiveness. All this and amen.
Anak, naka-off ang microphone mo.
So good morning again, grade 10. So I hope that you are doing fine. Let me check your attendance to know if there are any absent in our class. So class monitor of every group. So is there any absent in group 1? Mr. John Albert?
There are no absents in group 1 po.
Okay, that's good. How about in group 2? Miss Eliza?
There are no absents in group 2.
Okay, that is glad to hear that no one is absent in our class and you are ready to learn and gain new knowledge to our topic today. So, okay, so some classroom reminders. So, please remain open your cameras, and if you want to answer, just raise your hand and open your microphone. Is that clear, class?
Yes, sir.
Yes, sir.
Yes.
Yes po.
Yes po.
Okay, so let's watch this short video clip so that we are energized. So let's stand and let's dance together with this Energizer.
It's exciting, can't wait to see
We can't hear you, sir. Your microphone is off.
Okay, what a great moves, great 10. So you can go back to your most comfortable space. So let's have a recap on what we have discussed last week. So, okay, so you can raise your hand if you want to answer, or you can use our chat box if you know the answer. So let's start grade 10. Are you ready?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so our activity is entitled Don't Turn the Page Yet. Okay, so we need to have a recall first before we turn to the next chapter of our quarter 4. So my first question, what is the relationship between pressure and volume at constant temperature? Okay, Rain.
The relationship between pressure and volume at constant temperature is inversely proportional po.
Very good. So how do we calculate the final volume at in Boyle's law? How do we calculate the final volume in Boyle's law? What is our formula again in solving the final volume in Boyle's law? Yes, Eliza?
V sub F equals P sub 1 times V sub 1 all over P sub F.
Okay, very good. So we can also use the V sub 2 is equal to P sub 1 times V sub 1 over P sub 2. Okay, how do gases behave according to Boyle's law? Yes, Carmelin?
So Boyle's law states that the pressure and volume are inversely proportional to each other. As the pressure increases, the volume decreases, and as the pressure decreases, the volume increases.
Okay, that is correct. So how does pressure decreases when volume decreases? So why does pressure decreases when volume increases? Okay, let's call Limuel.
Because the volume has decreased, the particles will collide more frequently with the walls of the container. Each time they collide with the walls, they exert a force on them. More collisions mean more force, so the pressure will increase. When the volume decreases, the pressure increases.
Okay, very good. So what a great review, a grade 10. So you are all ready to move on to our next chapter in part 4. But before that, I prepared again another activity for you to be motivated. In English, vocabulary words are very important because it's used to sharpen the mind of the readers, and it is a key uh, for reading comprehension. So just like in science, it is used it is important for students to have a meaningful way on how to understood the different concept that may encounter in our a specific topic in science. So our activity is entitled Say My Name Before You Enter. So you need to guess a set of pictures, and I know that some of these terms are already encountered in your lower grade, and these vocabulary words that we may discuss is a very helpful in understanding the concept of Charles law. Okay, are you ready, class?
Yes po.
Yes,
Yes.
sir.
Sir.
Okay. For the game mechanics, you need to analyze every picture. Then guess the word or phrases that
Yes
can
po,
be
sir.
formed if you combine the group of pictures. And lastly, unmute or raise your hand if you know the answer. Is the instruction clear?
Yes po.
Yes
Yes.
po.
Yes po.
Yes
Okay,
po.
very good. So I prepared an example for you to be guided on how to uh, guess the set of pictures that I will present later. Okay, so what do you think is the word that can be formed in this sample? Yes, Realin?
Physics po.
Okay, very good. P6 is the correct answer for our sample. Okay, let's go to number 1. What do you think is this set of pictures? Yes, Arjex?
Temperature po.
Okay, that is temperature. How about number 2? Yes, John Albert?
Gas law po.
Okay, gas law. How about number 3? Yes, Lovely?
Volume po.
Okay, volume is the correct answer. And for number 4, yes, Ring?
Pressure po.
Okay, that is pressure. And for our last number, Tanika?
Atmosphere po.
Okay, that is atmosphere. Okay, congratulations to all students who guessed the set of pictures correctly. So you have now my permission to enter to our new topic. And before that, so let's have an experiment first before we proceed to the discussion of our new topic. So our experiment is entitled Hot and Cold Like You. Okay. So a short introduction. So in our new lesson, so in this lesson, you will learn about Charles' law, how to solve different sets of problems, and how this gas law is applicable in real life situation. Okay, so I recorded my own experiment for this topic for you to be guided on how to conduct our experiment. Then after watching the video, so it's your turn to do the activity on your own. Okay, is that clear, class?
Yes,
Yes
po.
po.
Yes po,
Okay, so
sir.
let me play the video.
Precautionary measures. Be careful in taking hot water in the bowl. Hold the bottle correctly and don't touch it while it's in the bowl with hot water. Don't play while doing the experiment. For the materials, we need a bottle, a bowl or container, a balloon. We must use a small size of balloon, and the hot water. For the procedure, first, get the bottle and a balloon. Place the balloon on the tip of the bottle. Put some hot water in the container. After that, place the bottle in the container with hot water and observe what will happen to the balloon. After a minute, remove the bottle from the bowl and let it cool. Observe what will happen to the balloon. If you want an immediate result, put some ice in one container and place the bottle or put the bottle in the freezer. From this experiment, it shows the application of Charles' law. As you can see, if there's a change in the temperature, there's a change in the volume of gas. To make it simple, volume and temperature is directly proportional with each other. Charles' law states that if there's an increase in temperature, the volume also increases. And when the temperature decreases, the volume also decreases.
Okay. So, we've done watching the recorded experiment. Then I will discuss again the precautionary measures that we need to uh, uh, remember. So first, be careful in putting hot water in the bowl. Second, hold the bottle correctly and don't touch it while it is in the bowl with hot water. And lastly, the most important is don't play while doing the experiment to avoid any danger or hazard while doing the experiments. Is that clear?
Yes po.
Yes.
Okay, I will give you 2 minutes to conduct the experiment and list down all your observations. Okay, you may now start doing the activity.
Precautionary measures. Be careful in putting hot water in the bowl. Hold the bottle correctly and don't touch it while it's in the bowl with hot water. Don't play while doing the experiment. For the materials, we need a bottle, a bowl or container, a balloon. We must use a small size of balloon and a hot water. For the procedure, first, get the bottle and a balloon. Place the balloon on the tip of the bottle. Put some hot water in the container. After that, place the bottle in the.
Okay, time's up. So I think that you are already done doing the experiment. Are you done?
Yes po.
Yes.
Okay. So let's proceed to the guide questions of the experiment. So while doing the experiment, so what happened when the balloon was placed in a hot water? Or how about in cold water? Anyone? Yes, Realin?
Sir, in hot water, the balloon inflated because of hot water air molecules, and in cold water, the balloon deflated because of cold air molecules.
Okay, very good. So what we can conclude for our question number 2, what can you conclude about what happened to the balloon when cold? Yes, lovely.
When a balloon is exposed to heat or cold, the gas inside the rubber will either expand or contract. The change in the balloon size becomes a visual gauge of the change in air pressure.
Okay, very good. That is correct. So when the balloon is exposed to heat or cold, the gas inside the rubber will either expand or contract. And how does gas in a balloon act when heated? Yes, Rain.
The pressure inside the hot air balloon is affected by temperature. As the molecules heat up, they move faster and strike the inside wall of the balloon harder. This increased motion of the gas particles increases the force on an area of the balloon, producing a rise in the pressure.
Okay, very good. So this activity has something to do with our topic, which is Charles Law that we will be discussed today. So I hope that you enjoy our experiment about balloon experiment of applying the concept of Charles Law. Okay, so let's start with the discussion of Charles Law, the volume temperature relationship. Okay, please read the objectives, Miss Queen.
Objectives. Number one, state Charles' law. Number two, investigate the relationship between volume and temperature at constant pressure. Number three, solve problems involving changes in the condition of the gas using the equation for Charles' law. And number four, recognize the importance of Charles' law in a real-life situation.
Okay, thank you. So these four objectives should be achieved um, along the discussion and after the discussion of Charles Law. Okay, who is Jacques Charles? Anyone? Who is Jacques Charles? Yes, Michelle.
Jacques Alexander Cesar Charles was a mathematician and physicist, remembered for his pioneering work with gases and hydrogen balloon flights. Charles was born on November 12, 1746 in Bregency-Loire, France. His first occupation was a clerk at the Ministry of Finance in Paris. However, his interest eventually turned to science.
Okay, thank you. So Jacques Charles is best known for the concept of the hot air balloon. And these are the measurable properties of gas that we may encounter in Charles' law. Please read the measurable properties of gas. Yes, Carmeline?
Measurable properties of gas. Volume. Defined as the space occupied. The volume of the gas is equal to the volume of the vessel or container. Temperature. Defined as the degree of hotness or coldness. Pressure. The force exerted by the gas on the walls of its container divided by the surface area of the container.
Okay, thank you. So when we say volume, this is the space occupied or this is the space occupied by the gas particles inside the container. And when we say temperature, this is the degree of hotness or coldness. And lastly, the pressure, the force exerted by the gas on the walls of its container. So these three measurable properties of gas are related to each other because if there's an increase in one of them, so there are change in other properties of gas. Okay, Charles' law states that the Kelvin temperature and the volume of gas are directly related when there is no change in pressure or amount of gas. To convert temperature from degrees Celsius to Kelvin, you need to add 273. So take note that when converting from Celsius to Kelvin, you just need to add 273 to make it in Kelvin. Again, it said that in Charles' law, so the temperature and the gas are directly proportional with each other if there's no change in pressure or amount of gas or the gas particles. As you can see in our diagram or illustration, so you can see that if there's an increase in temperature, the volume of the gas is also increasing. And if we lower the temperature, so the volume of the gas will decrease. Understood, class?
Yes, sir.
Okay, so to further give you an idea on some informations about Charles' law, so we will use PET correlado simulations for you to know how Charles' law works. So I will send you the link of the simulations on our chat box. Okay, so please click the link that I sent on our chat box. Okay, so choose the ideal gas properties after you click the link. Are you able to access the link that I sent on our chat box?
Yes po.
Okay, so let's start the simulation. So I want you to put some gas inside the container by pumping the hand pump beside the container, the color violet. So you need to pull the hand pump and push it to have these gas particles inside the container. So what have you observed in the gas particles inside the container? Anyone? What have you observed? Yes, Rayalyn?
Slowly move po.
Okay, there are no the gas particles is stable state. So next thing to do is we must hold the pressure in constant. So as you can see on the upper right, there are variables. So we need to press the pressure to make it constant. Then,
Yes po, sir.
okay. Next thing to do is apply heat or higher the temperature. Okay, so what happened to the volume when we increase the temperature at constant pressure? Anyone? Yes, Eliza?
The volume increases po.
Okay, very good. So the volume is increasing as the temperature is increasing. How about when we lower the temperature? What have you observed? Yes, Carmeline?
I observed that the volume is decreasing and the particles are slowly moving.
Okay, very good. So the gas particles is starting to move slowly and the volume is decreasing. Okay. So from our simulation, so we understand how Charles' law work. Then let's continue our discussions about Charles' law. So a direct relationship is one in which the related properties increases or decrease together. For two different conditions, the ratio of V to temperature T is constant as long as pressure P and number of moles do not change. Again, from our simulations, as you observe, so if there's a increase in temperature, the volume also increases. And when the temperature decreases, the temperature also decreases. So we use a mathematical equations here in solving the different word problems using the concept of Charles' law. So we use B sub 1 over T sub 1 is equal to B sub 2 over T sub 2. So just like in mathematics, so we use an equation to solve a problems. In science, we also use a mathematical equation to solve a different problem solving. Do you have any questions about the Charles law, grade 10?
None po,
Wala
sir.
po.
Wala po.
Okay, thank you for the confirmation. I'm glad that you understand our discussion. So this table shows the unit used in measuring temperature and volume. So for measuring the volume, we use milliliter, cubic centimeter, and liter. So 1,000 milliliter is equal to 1 liter. So if we convert to milliliter to liter. Next one is the units in measuring the volume. So we just use 2 units, the Celsius and Kelvin. Again, to convert Celsius to Kelvin, you need to add 273. For example, we have 20 degrees Celsius. So if we convert it to Kelvin, we need to add 273 in 20 degrees Celsius, and we can get 293 Kelvin. Are you able to follow in converting the temperature from Celsius to Kelvin?
Yes po.
Yes, po.
Yes po.
Okay. Okay, so let's analyze and solve this sample problem. Please read the sample problem. Yes, John Albert.
A neon gas of 760 millimeter Hg has a volume of 12.0 liters and a temperature of 44 degrees Celsius. Find the new volume of the gas after the temperature has been increased to 85 degrees Celsius at 760 torr.
Okay, thank you. So a neon gas at 760 millimeter of mercury has a volume of 12 liter and a temperature of 44 degrees Celsius. Find the new volume of the gas after the temperature has been increased to 85 degrees Celsius at 760 torricelli. So 760 millimeter of mercury and 760 torricelli is equivalent to 1 atmosphere. So there are no changes in pressure. So the pressure is still constant. For our solution, so we need to convert the temperature to Kelvin because it is stated in Celsius. So since the temperatures are given in degrees Celsius, you must first change them into Kelvin. So our initial temperature, which is 44 degrees Celsius, so we need to add 273 and we can get 317 Kelvin. And for the final temperature, 85 degrees Celsius plus 273 is equal to 358 Kelvin. Okay, so after we convert the temperature, so we need to jot down the given value of the variable. So now our initial temperature is 317 Kelvin and initial volume is 12 liter. Then for the final temperature, we have 358 Kelvin and we need to find the value of the final volume. So take note that the temperature is increasing so that our final volume should be increased. Okay. For our step number 3, so according to the temperature volume relationship, so we use the mathematical equation B sub 1 is over T sub 1 is equal to V sub 2 over T sub 2. Then to derive a new formula, because we need to find the final volume, so we need to derive a new formula by cross multiplication. So we need to cross multiply the mathematical equations. So we can get V sub 1 times T sub 2 is equal to V sub 2 times T sub 1. Then we need to divide both sides with T sub 1. To cancel the T sub 1 on the right side, and uh, we need to retain the V sub 2. So our final formula for solving the final volume is V sub 2 is equal to V sub 1 times T sub 2 over T sub 1. The variable. So for the V sub 1, we have 12 liter multiply 2 T sub 2, which is 358 Kelvin over T sub 1, which is 317 Kelvin. So when we solve this, so we can get 13.55 liter or 13.6 liter. So the final volume of 13.6 liter is larger compared to the initial volume of 12 liter as the temperature increases. So you can see the relationship between the temperature and volume in solving this sample problem. Again, what is the relationship between the temperature and volume at constant pressure? Anyone? Yes, Carmeline?
The relationship of it is as the temperature increases, the volume also increases, and as the volume decreases, the as the temperature decreases, the volume also decreases.
Okay, very good. That is correct. As the temperature increases, the volume also increases. As the temperature decreases, the volume also decreases. Okay, so that is the Charles law. Okay. For our next activity, so I will group you into two, and each group will solve a one set of problem solving. Then after solving this, so one representative from your group will present and explain your answer. Okay, so I will send the link of the Jamboard where you can post your answer. Okay, I already sent the link for our Jamboard. Next is wait for a moment. So for your groupings, so the group one, so I sent again the groupings for our activity. Then our group leader for group one is John Albert, and for group two is Eliza. Okay, for the problem solving of group one, a balloon is filled to a volume of 3.20 liter at a temperature of 25 degrees Celsius. The balloon is then heated to a temperature of 75 degrees Celsius. Find the new volume of the balloon. And for group 2, during the day at 300 Kelvin, a cylinder with a sliding top contains 20 liters of air. At night, it only holds 19 liters. What is the temperature at night? Okay, you may now start solving the problem. Okay, I can see lots of students on our Jamboard. But okay, group one already have an answer. Let's check the group two. Okay, you can still have 1 minute. Okay, time's up. Okay, group one, please present your answer on our problem solving. Mr. John Albert.
Our group 1 problem is a balloon is filled to a volume of 3.20 liters at a temperature of 25 degrees Celsius. The balloon is then heated to a temperature of 7 degrees Celsius. Find the new volume of the balloon. So the given is V sub 1 is equal to 3.20 liters. T sub 1 is equal to 25 degrees Celsius converted to T sub 1 equals 25 degrees Celsius plus 273 is equal to 298 Kelvin. T sub 2 is equal to 75 degrees Celsius is converted to T sub 2 is equal to 75 degrees Celsius plus 273 is equal to 348 Kelvin. So, ang hinahanap po natin dito is V sub 2. Ang solution po is V sub 1 over T sub 1 is equal to V sub 2 over T sub 2 converted to V sub 1 times T sub 2 over T sub 1 is equal to V sub 2 times T sub 1 over T sub 1. Cancel po ang T sub 1. So, magiging V sub 2 is equal to V sub 1 times T sub 2 over T sub 1. V sub 2 is equal to 3.20 liters times 348 Kelvin over 298 Kelvin. Cancel po ang Kelvin. So, magiging V sub 2 is equal to 1,113.6 liters over 298. So, ang magiging final answer po is V sub 2 is equal to 3.74 liters.
Sir, wala kang sound. Naka-off ang mic mo.
Okay, sorry po. So the final volume from problem number 1 is 3.74 liter. How about group 2, Miss Eliza?
Good morning, everyone. This is the presentation of Group 2. For our problem, during the day at 300 Kelvin, a cylinder with a sliding top contains 20 liters of air. At night, it only holds 19 liters. What is the temperature at night? The given are T sub 1 equals 300 Kelvin, V sub 1 equals 20 liters, V sub 2 equals 19 liters, and the missing is T sub 2. For the solution, cross multiplication of V sub 1 all over T sub 1 equals V sub 2 all over T sub 2. It will be V sub 1 times T sub 2 all over V sub 1 equals b sub 2 times t sub 1 all over b sub 1. So the b sub 1 will be cancelled. So it will be t sub 2 equals v sub 2 times t sub 1 all over v sub 1. For the substitution, t sub 2 equals 19 liters multiplied by 300 Kelvin all over 200 K. For the T sub 2, 19 K 19 times 300 equals 5,700 K all over 20. The final answer is 285 K.
Okay, very good. The final temperature at night is 285 Kelvin. So the temperature is also decreasing at night. Okay, so congratulations to our group. So you all solved the word problems correctly. So give yourself a round of applause. Discussing the Charles law, and we also know how to apply Charles law in solving word problems. Now, I want you to test what is your overall learnings from our discussion. So, what is the importance of Charles law in our everyday lives? How does it work in a real life situation? So, please give some example of the real life application of Charles law. Anyone who can give me an example? Yes, John Albert.
Like a hot air balloon po. When a gas is heated, it expands. As the expansion of the gas takes place, it becomes less dense and the balloon is lifted in the air. The warm is less dense than the cold air, which means that it is lighter than the cold air.
Okay, very good. So, Charles law is applicable in hot air balloon. Another example, anyone? Yes, Carmelin.
Another example is the in the real life situation can be in our kitchen. In order to make bread and cake soft and spongy, yeast is used for fermentation. Yeast produces carbon dioxide gas. When bread and cakes are baked at high temperature with an increased temperature, carbon dioxide gas expands.
Okay, very good. That is a nice application of Charles law. Another example, yes, Rain.
Another example po is bottle deodorant spray. Under high temperatures, the air molecules inside the bottle will expand, which can lead to the bursting of the deodorant bottle. Don't place the bottle from direct sunlight and high temperature.
Okay, very good. So another example is the bottle deodorant spray. So if you observe some bottle or some products, it stated on the label that keep the product away from the increasing from 30 degrees Celsius because it may explode or burst if the that certain product is exposed to higher temperature. Then another example, is there any application of Charles law? Yes, Rayalyn?
The other example po ay ping pong ball. If you play ping pong, chances are you've come across the occasionally dented ball. Restore its roundness by popping it in a pan of water. Warm the water gently while stirring and the air inside the ball will expand as it heats up. The expanding air will push out the dent and restore the ball's roundness.
Okay, very good. So it's applicable in ping pong ball and especially to the ball used in playing basketball. So if you leave the basketball ball in the place where there is lower temperatures, you will observe that the ball is shrinking. Then if you place it on a place that have a higher temperature, so it will bring back into the original shape, which is round. So it will inflate again, even it is shrink from the lower temperature. So that are the some example of application of Charles law. I am glad that all of you are learn from our discussion of Charles law. So to test your understanding about Charles law, so let's answer this assessment. Let me tease you. So we will use an ed form to collect your answer. So I will send the link in our chat box. We already sent the link in our chat box. You may now access. Uh, you have 5 minutes to answer our assessment. Please. So most of you gets the perfect score in our assessment. I'm glad. Okay, so while other still answering the assessment, so let me explain your assignment. So let's answer our assessment. Okay, I think that everyone is done answering our assessment. So let's discuss the answer in our assessment. For number one, so the relationship of which two variables are compared in Charles' law, it is a pressure and volume, B volume and temperature, C temperature and pressure, D volume and moles. Anyone? Yes, Camille.
Letter B po, volume and temperature.
Okay. This is volume and temperature. Number two, please read. Okay. So number two, Wesley and Wade are playing basketball outside in 82 degrees Celsius weather. If they leave the ball outside, the temperature drops down to 53 degrees Celsius. What will happen to the volume of the gas in the bowl if the pressure remains constant? So the correct answer is volume will decrease. For number three, at the constant pressure, what happens to temperature of gas when the volume doubles? So the correct answer is for number three. What's the answer? Yes, Carmeline.
Letter A po.
Okay, that temperature also doubles. For number four, for the problem below, what's the initial volume? Aries and Wade want to play a game of beach volleyball. If the beach ball has a volume of 400 liter at a temperature 500 Kelvin, what will the temperature of the balloon be if the volume decreases to 176 liter? Anyone? Okay, so Cheryl.
400 liter po.
Okay, the correct answer is 400 liter. And for last number, Charles' law is an experimental gas law that describes how gases tend to expand when heated. The law states that if a quantity of gas is held at a blank pressure, there is a blank relationship between its volume and the temperature. So what is the answer? Yes, Limuel.
Letter A po, constant direct.
Okay. Constant pressure and direct relationship. Okay. Okay, we are through discussing the answer in our assessment. So let's proceed now to our assessment. So congratulations to all students who get a perfect score. So give yourself a round of applause. So please read our assignment. Yes, Carmeline.
A canister of gas has a volume of 1,500 ml at 320 Kelvin. What volume the gas occupy at 273 Kelvin if the pressure remains constant?
Okay, so for our assignment, so you need to find the final volume for this word problem. So our initial volume is 1,500 milliliter and initial temperature is 320 Kelvin and the final temperature is 273 Kelvin. So you need to find the value of final volume. And for another assignment, so please read some articles about the biomolecules because that is our next topic next week. So don't forget that to read some articles. Is that clear, class?
Yes, sir.
Yes po.
Yes po.
Yes
Okay.
po.
Again, so do you have any questions and clarification about the assignment?
None po.
Wala na po.
Yan po, sir.
Thank you for the confirmation. So Thank you, class, for the active participations for our lesson. So, God bless everyone. So, class dismissed. You may now leave in our Google Meet.
Thank
See
you
you
po.
on
Thank you
next.
po.
Thank you po. Thank you po.
Thank you.
Hello po, Dean.
Hello po.
Ngayon na din po ba ang post-conference? Dito
Okay
na
lang
rin?
po kung ma'am after mamaya kasi ako lang ay may emergency. I will be
Sige po. Ako din po ay may training. Nasa division na ako.
yeah, I will be sending Dr. Faltado to attend the second demonstration.
Sige po. Sige po.
Okay, please understand ano po. Thank you.
Sige po. Sige po.
Okay.
Permission to leave.
Yes po, me too.
Thank you sa mga umattend at pwede na mag-leave yung si Sir nila lang at kami ang matitira dito sa Jimmy. Thank you so much. Jiten Mahogany, Yakal, Lara, Akasha. Sir Neil, Good morning, Ma'am Gailey. Nag-leave yata ang Ma'am Gailey. Ay naku, nag-leave na nga ang Ma'am Gailey. Yan. Okay, stop mo na yung recording.
May po mag-stop.
Ha?